Good morning, Year 9. This is Miss Teresa. Today, we are going to learn all about power. Our lesson objective for today is to explain the concept of power and success criteria, relate power to work done and time taken using appropriate examples. This is Paul. He weighs 65 kilograms. This is Pablo. He is 65 kilograms as well. They will both travel from point A to point B at a distance of 50 meters. Paul chose to run from point A to point B, while Pablo chose to walk leisurely. Paul reached point B in 8 seconds, and Pablo reached the same point in 36 seconds. Question: who did more work, Paul or Pablo? Before we answer that, we're going to have a quick recap about work. Work is done whenever a force makes something move. The greater the force and the greater the distance moved, the more work is done. And when work is done, energy is transferred from one form into another. Work done is equal to force times distance. In symbol, W is equal to F times D, and work is measured in joules. So, going back to our question, who did more work? According to our definition of work, they both did the same amount. Both are 65 kilograms and both moved 50 meters. Therefore, if we're going to calculate work, it's equal to 65 kilograms times 10 Newton per kilogram times 50 meters. It will give us 32,500 joules of work. But Paul did the same amount of work in a lesser amount of time. Therefore, Paul has more power. What's power? Power is the rate at which work is done. The unit of power is the watt, and 1 watt is work done at the rate of 1 joule per second. 1 watt is equal to 1 joule per second. Power is equal to work done divided by time taken. 1000 watts is equal to 1 kilowatt. This table will give you typical power outputs. Let's go to problem solving. A hairdryer does 48,000 joules of work in 1 minute. What is the power rating of the hairdryer? So we know that P is equal to work divided by time. The work given here is 48,000 joules. 48,000 joules divided by 1 minute. 1 minute we have to convert to 60 seconds because we know that power is 1 joule per second, so we need seconds as our SI unit for time. So this will be 60 seconds, which is 1 minute, so joule per second. Now going to our calculator, 48,000 divided by 60 is equal to 800 joule per second, or we can use watts. So this is the answer for this problem. Next problem. 3 boxes each weigh 100 Newton. A man lifts all the boxes together from the ground onto a shelf that is 1.5 meters above the ground. The man takes 2 seconds to do this. So this work is done against gravity. So we are going to use work formula. W is equal to F into H. And we know that P is equal to work done, which is now equal to F times H divided by time. So there's no need for conversion. Everything is in the proper SI units. Therefore, we're just going to substitute. P now is equal to force. We're going to use 300 for the force because there are 3 boxes each weighing 100 Newton. Therefore, 300 times the height is 1.5 from the ground divided by the time, which is 2 seconds. Now, calculating this, we're going to get 225 joule per second, or just watts is fine. If you chose to use joule per second as the SI unit, is fine. If you're going to use what, is also fine. Okay, next problem. You already know that the rest of these problems will be yours to solve, and you're going to write the answers in your notebook together with the answers to the questions given to you to summarize this lesson. Therefore, today we have related power to work done and time taken using appropriate examples. This is the end of our lesson. I hope you enjoyed it, and this is Mr. Essa signing off. Have a nice day.